Hiya, Kiki here, and today I'm going to provide you with an overview of our curriculum, Introduction to Computer Science with Microsoft MakeCode Arcade. This curriculum invites a broad spectrum of high school students to dive into the foundational concepts of computational thinking and programming in a way that's both accessible and engaging. MakeCode Arcade stands out as an exceptionally approachable platform. It begins with a block-based coding environment that welcomes newcomers into the coding scene. As the course progresses, it transitions into text-based programming with options in JavaScript or Python, catering to growing skills and expanding curiosities. MakeCode Arcade is free to use and web-based, which means it doesn't require any software installations or significant hardware capabilities. This makes it easily accessible for most educational institutions and homes, no matter what brand of computer you're using, reducing barriers to entry for learning to code. One of my favorite reasons to use MakeCode Arcade as an introductory coding platform is the gaming aspect. Pew Research says that 85% of American teenagers play video games regularly. This number persists across different racial and ethnic groups, as well as households with differing annual incomes. While some students have a tendency to go into game design with expectations of Halo or Call of Duty, which are relatively unrealistic for a beginner with a budget less than $250 million, the pixelated retro style of MakeCode Arcade right-sizes expectations in the direction of Pac-Man and Super Mario Bros., both of which can be used as inspiration for a single level designed within an hour during Term 1. Another standout feature of MakeCode Arcade is the ability to see the results of your code immediately. This real-time feedback helps students quickly understand the effects of changes and adjustments, fostering a more engaging and responsive learning experience. Let's talk structure. The backbone of this course is its project-based nature. About 75% of your time will be devoted to hands-on projects that not only consolidate learning, but also ignite the spark of creation. Each unit concludes with a comprehensive project, turning abstract concepts into tangible outcomes that students play, share, and take pride in. Students are encouraged to independently navigate challenges, utilizing the digital toolbox to find solutions. This self-sufficiency fosters critical thinking and problem-solving skills as students try different approaches to overcome obstacles. Educators guide this exploratory process by posing strategic questions rather than providing direct answers. Most lesson plans in this curriculum are designed to represent a single 55-minute class period with average pacing. Each class will have slightly different needs, possibly including different period lengths, student capabilities, classroom interruptions, and more. Teachers and volunteers are encouraged to consider the pacing guides in the unit overview documents and the planning calendar Excel workbook as guidance for one possible use of time to present the material. Feel free to adapt the lesson plans as necessary to fit the needs of your own classes. With a few exceptions, each lesson consists of the following components. 5 minutes are allotted at the beginning of each day for administrative tasks such as taking attendance, giving announcements, returning work, and other necessary actions. During this time, teachers are encouraged to assign bell ringer activities. These activities aim to engage students with the subject immediately upon entering the room. They should be short, clear, and able to be completed by all students. Most lessons begin with a brief period of instruction on the topic of the day. These should be kept as brief as possible because the primary means of student learning in most lessons will be the lab activity. activities. It's intended that the labs are structured well enough for students to work on their own. But teachers should feel free to interject at appropriate points to assess student progress and provide additional guidance as necessary. After each activity is concluded, time's allotted for teachers to review and debrief the activities with students. Rather than presenting solutions to each step of the lab, teachers are encouraged to use the debrief time to focus on particularly tricky or noteworthy parts of the lab, or to discuss areas where students struggled. Debrief time can also be used to compare different approaches to some problems, emphasizing that, in most cases, there is more than one valid solution. Whenever possible, use examples of student work rather than instructor-created solutions during the debrief. This is an excellent chance to showcase students who solve problems in an elegant, creative, or canonical way. This curriculum is divided into two distinct terms. First semester is block-based learning. Students learn about the course, classroom environment, algorithms, and MakeCode Arcade environment. Students learn the basics of the core entity in MakeCode Arcade, the sprites. Students learn about event handlers available in MakeCode Arcade. They're also introduced to variables, strings, and decision structures. Students learn about definite and indefinite loops and their application to arrays. They're also introduced to frame-based animation. Students learn to write functions as a problem-solving technique and to encourage code reuse. In this optional unit, students learn about tile maps and their myriad of uses, including platformer games. Students work in teams to create complex projects. They'll also create marketing materials for their projects. The second semester is text-based coding. You can choose from JavaScript or Python. In this optional unit, students revisit the core concepts that they learned in the blocks environment. This unit is intended for semesters that don't immediately follow the block semester. Students transition to a typing language, either static TypeScript, aka JavaScript, or static typed Python, simply called Python in the course materials. Students revisit core topics from Units 2 and 3 in the blocks course, extending their skills where appropriate. Students implement functions in their typing language. Students learn very basic object-oriented programming and design techniques, focusing on subclasses that inherit from the sprite class. In this optional unit, students create projects that leverage tile maps, including platformer games. In this optional unit, students work with advanced graphic techniques, including parallax and mini-maps. Students work in teams to create complex projects with text. They also create marketing materials for their projects. Relevant materials are provided for each lesson to maximize engagement and learning. We provide a selection of bell ringer activities to set the tone and energize your mind. You'll find detailed roadmaps for each lesson, including objectives and key teaching points. We also provide visual aids to simplify complex ideas, making learning more intuitive. Student guides are your hands-on companions in the lab, where the real magic happens. Most of our content can be adapted to remote instruction with few changes, since a good amount of class time is devoted to independent work. If your remote instruction platform supports breakout rooms, students can break out into small groups that we call helping trios, so students can learn to rely on their teammates for assistance before requesting help from instructors. I encourage you to actively engage on the MakeCode forum at forum.makecode.com. It's a wonderful space for exchanging ideas, seeking advice, and even sharing your own innovations. Make sure you also follow our MakeCode YouTube channel and our Educator Resource channel. Our teams will also be readily available on the platform formerly known as Twitter, using @MSMITCode. Thank you for being here, for your dedication to your students, and for your commitment to education. Together, let's inspire the next generation of thinkers, makers, and leaders. Here's to a fantastic journey ahead in computer science. Until next time, happy coding.